Have you ever wondered, can we build something like a ChatGPT vision that can read a screenshot, extract text, describe images, or even analyze UI designs without sending a single image to OpenAI? No API keys, no internet, no cloud. Everything running completely on your machine. I believe this is one of the coolest AI projects you can build today. And by the end of this video, you will understand not only how to build it, but also how the entire architecture works behind the scenes. Let's dive in. If you're new here, we build practical AI systems, local LLM applications, AI agents, and explain how they work internally. Today's project is an AI image scanner powered by Streamlit, Ollama, vision models like LLaVA Moondream. The best part, everything runs locally. Let's first see what we are building. I can upload screenshot, even photo. I can ask, describe this image, or extract all the text, or what UI components do you see? Within seconds, the local vision model understands the image and responds. Everything is happening locally. Now let's understand how this works. At very high level, our architecture is surprisingly simple. User, you and me, interacts with the app using the Streamlit UI. Streamlit UI behind the scene executes the application logic whenever we interact with the UI. Application logic built in Ollama Runtime library, which interacts with the different vision models like a LLaVA or Moondream, and LLaVA or Moondream, the model digests the image and understands our prompt and gives us the response. And all the responses will be kept on your local history storage for subsequent usage, for subsequent context. That's literally the entire pipeline. Now that we understand the architecture, let's move on to the fun part, building and running the project. To make things easy, I have already uploaded the complete source code to my GitHub repository, the Curious Architect 09. Head over to the GitHub, open the local vision Ollama Streamlit repository, and clone it to your local machine. Once the repository has been cloned, open the project in VS Code and take a quick look at the README MD file. It contains all the setup instructions and we will follow them step by step. The first prerequisite is Ollama. If you haven't installed it, you can either install it using Homebrew with the command, or simply visit the Ollama website, download the installer for your operating system and complete the installation. After the installation is complete, start the Ollama server by running Ollama serve. For this project, we will be using two vision models, LLaVA and Moondream. If these two models aren't already available on your machine, install them using the Ollama pull command. Once the downloads finish, verify that everything is installed correctly by running Ollama list. If you can see both models listed, we are ready to move on. Next, open the project on your terminal and activate the project's virtual environment. Using a virtual environment keeps all the dependencies isolated to this project, which is always a good practice for Python development. After activating the environment, install all required Python packages using the requirements.txt file. With everything installed, launch the application by running streamlit run app.py. Within few seconds, Streamlit will display a local URL, usually running on the port 8501. Copy that URL, open it into your browser, and you will see the application we have built from scratch. The interface is entirely built using Streamlit, making it lightweight, clean, and easy to use. One of the nice features of this application is that you can switch between multiple vision models with just one click. For this demo, let's upload the OpenAI Enterprise Virtual Assistant Architecture diagram and ask the model to analyze the image. By default, the application is configured to use the latest Moondream model. Once we click Analyze, the model inspects the image and generates a detailed description of everything it detects. Now let's try something interesting. We will switch the model to LLaVA and analyze the exact image again. Notice how the response changes. Different vision models have a different strengths. So the quality, level of detail, and interpretation can vary significantly. This is one of my favorite features of this application. You can easily compare multiple vision models on the same image and decide which one performs best for your specific use case. And that's it. That's it. We have successfully built and tested 100% local AI image scanner powered by Streamlit, Ollama, and open source vision models with absolutely no cloud dependencies. The important thing to remember is Ollama acts like a local AI server. Instead of calling OpenAI APIs, our application talks to localhost. Everything happens inside your machine, no data leaving your local system. Layer 1, user layer. Let's start from the top. The first layer is obviously the user. The user uploads an image, maybe it's a screenshot, invoice, chart, document, UI mockup. Then selects a task, for example, extract text, describe image, analyze UI, compare models. Then optionally selects which AI model should I answer. Maybe LLaVA, maybe Moondream. Notice something interesting? This layer contains zero intelligence. It simply collects the user intent. Layer 2 is the Streamlit application. Now the request enters our Streamlit application. This is why the most beginners think AI is happening. But actually this layer is acting more like an orchestrator. Let's break it down. UI, this is where everything you see. You upload a file, you select different models, you see buttons, you see a prompt box, compare toggle, etc. That's the UI layer. And the application logic, now comes the interesting part. Like once you click analyze, our application begins orchestrating everything. First, it validates the input. Did the user upload an image? Did they choose a model? If not, show an error. Next, it constructs the prompt. Instead of simply sending describe image, we can enrich it, for example, extract all readable text, preserve formatting, ignore decorative graphics. Prompt engineering starts here, not inside Ollama, inside your application. After that, we route the request. If the user selected model is LLaVA, send it there. If they selected Moondream, send it there instead. Same application, different AI brains. That's the beauty of the model abstraction. Utilities layer. Before Ollama can understand the image, we need preprocessing. This is handled inside our utility functions. For example, convert images to RGB, resize our large images, extract metadata, convert image into base64. Why? Because Ollama expects images as base64 strings inside the API request. Without this conversion, the model can't see your image. Here comes the magical part, Ollama Runtime. Our application makes an HTTP request to localhost 434. This is Ollama's local server. The request looks something like this. Model, prompt, image, streaming option. Notice, we are not uploading anything to the cloud. We are simply talking to another application running on our laptop. Think of Ollama exactly like a database server, except instead of storing data, it serves AI models. Now let's see how the vision model execution happens. Inside Ollama, the selected vision model starts working. For example, LLaVA. The image first goes through something called vision encoder. The encoder converts pixels into embeddings. Meanwhile, your prompt, like extract text, goes into the language model. Finally, both are combined. The language model now understands both what it sees and what you are asking. This produces the final response. That's a multi-AI in action. Image plus language together. So we have a storage, right? We build a storage in our local. Once the response comes back, our application doesn't simply display it. It also saves everything locally, maybe inside CSV file. That includes timestamp, model, prompt, response, image name. This gives us a lightweight history perfect for debugging, auditing, or comparing different models later. You can even export everything as a markdown. Compare mode, one of the features we are developing in this application. Instead of asking just one model, we can ask two, LLaVA Moondream in our case. Same image, same prompt, then compares their responses side by side. This is incredibly useful when evaluating vision models to figure out what is the best model for our screen reading. I believe there are 5 reasons this architecture is so clean. First, it's completely local, no API costs. Second, every layer has a single responsibility. UI, application, inference, models, storage, everything has a single responsibility. Third, models are pluggable. And tomorrow, if a better vision model appears, you simply change the model name. Everything else remains identical. Fourth, every request is stateless, simple, reliable, easy to scale, and finally, it's enterprise friendly. No screenshot leave the company laptop. No sensitive document reach external servers. This makes it ideal for financial organizations, healthcare, government, or internal enterprise tools. Now imagine extending this project. Instead of one image, scan an entire folder. Add PDF understanding, generate summaries, detect UI bugs, analyze dashboards, build an AI QA assistant, or even connect it to an AI agent. This simple architecture becomes the foundation for much larger AI systems. That's how an AI image scanner works completely offline using Ollama and Streamlit. I believe once you understand this architecture, building a local AI application becomes much less intimidating. If you enjoy this video, hit that like button, subscribe for more practical AI architecture videos, and let me know in the comment what local AI project you like me to build next. I will see you in the next one.